Every day, we recognize intelligence without thinking about it. A child learning to speak, a doctor diagnosing a patient, a musician composing a melody, a scientist discovering a new law of nature. But what exactly is intelligence? Before we ask whether machines can become intelligent, we must first understand what intelligence truly means.
Back in 1950, the brilliant British mathematician Alan Turing published a paper titled Computing Machinery and Intelligence. And in it, he asked this deceptively simple yet incredibly profound question: can machines think? Instead of trying to rigidly define what thinking is, Turing actually proposed a test. He figured if a human interacts with a machine and another human, and the machine perfectly mimics the human, well, maybe it could be considered intelligent. That single idea essentially laid the philosophical foundation for a 70-year quest to recreate the human mind.
Now, the journey to actually answer Turing's question, it definitely wasn't a straight line of success driven by just one person. AI officially started at the Dartmouth Conference in 1956, but from there, it is really a story of failures, sheer persistence, and staggering breakthroughs. You have to remember, each generation of scientists, mathematicians, and psychologists built entirely on the discoveries of the people who came before them.
Okay, let's start with Section 1, the era of logic.
Back in the 1950s, researchers were just incredibly ambitious. They thought, hey, if humans think logically, computers could be programmed to do the exact same thing using math. This idea really hit its peak in the 1980s with what they called expert systems. Scientists would basically take thousands of explicit rules from human experts, like doctors, and store them directly into a computer to diagnose patients in really narrow domains. But they hit a massive wall. These systems just struggled to adapt. Maintaining thousands of manual rules was impossibly expensive, and honestly, the machines completely lacked any true learning capability.
When those early promises fell flat, the field entered what we now call the AI winters. These were dark periods, especially in the 70s and 80s. Primitive computers back then simply lacked the memory, the data, and the processing power to actually fulfill these scientists' grand ambitions. Funding was completely slashed, progress slowed to a crawl, and honestly, a lot of people actually believed AI had just totally failed.
Which brings us to Section 2, the paradigm shift.
As we rolled into the 1990s and 2000s, an absolute explosion of internet data and powerful processing triggered a massive philosophical pivot in computer science. See, traditional computers are incredibly fast calculators, but they don't actually understand meaning. They just blindly execute explicit instructions written by humans. Machine learning was a radical shift from that. Instead of writing rigid rules for every possible scenario, scientists designed algorithms that allowed machines to learn statistical patterns from examples. Essentially, the machine started to learn on its own.
Let's trace how this learning actually evolved. Step 1 takes us all the way back to 1958 when Frank Rosenblatt develops the perceptron. It was inspired by biological neurons in the human brain, designed to learn simple patterns. For decades, a lot of experts thought these artificial neural networks were a dead end. But thanks to relentless persistence, we reached Step 2, deep learning, where networks could finally learn incredibly abstract patterns. And finally, Step 3, the modern architecture we use today, transformers, which can evaluate complex relationships across just massive, massive amounts of data.
The world truly woke up to this power in 2012. That year, a neural network called AlexNet absolutely dominated a major image recognition competition. It proved unequivocally to the scientific community that deep learning actually worked. It was literally the moment that transformed AI forever.
So that leads us perfectly into Section 3. What is intelligence?
Here's the crazy part. Despite 70 years of exhaustive research by thousands of psychologists, linguists, neuroscientists, and engineers, there is still no universally accepted definition of intelligence. None. We know it exists on this vast spectrum across nature. I mean, you have crows crafting tools, dolphins communicating, octopuses solving complex puzzles, and elephants remembering locations. And then you have the profound emotional depth, musical genius, and logical reasoning found in humans. We know intelligence when we see it, but boxing it into one single definition, it seems almost impossible.
So instead of a rigid definition, we kind of have to observe its characteristics.
Think of it like this. Imagine two students. One memorizes every single answer for a test without understanding a thing, while the other deeply grasps the concepts and can solve entirely new, unfamiliar problems. Human intelligence is about that true understanding. It's incredibly adaptable. It's our ability to learn from experience, adapt to unfamiliar situations, grasp the nuances of language, plan ahead, and make decisions when things are totally uncertain. We possess so many different kinds of intelligence, not just one single ability.
Now, artificial intelligence, it contrasts pretty sharply with that human experience. Modern AI systems like ChatGPT absolutely do not possess consciousness, emotions, desires, or self-awareness. They just don't have beliefs. What they actually do is recognize statistical patterns in enormous amounts of training data to predict useful outputs. They simulate aspects of intelligent behavior brilliantly, but they do it without any true human-like understanding.
So on one side, you have the human mind possessing conscious reasoning, true understanding, and imagination. On the other side, modern AI relies entirely on highly advanced statistical prediction. Sure, AI systems can master incredibly complex tasks, like defeating world champions at the board game Go, but these are what we call narrow AI, because they are designed for very specific tasks. Their version of thinking is fundamentally completely different from ours.
And that brings us to Section 4, the language barrier.
For decades, teaching a computer to actually understand language was literally the hardest problem for traditional computers to crack. Take a really simple sentence. The bank is crowded. As a human, you instantly use context to know the meaning, right? Are we talking about a financial institution with a long line or the side of a river packed with people fishing? You just know instantly based on the conversation. But early AI, it stumbled completely.
Early AI failed miserably here because it relied on manually written grammar rules and dictionaries. But human language is inherently messy. It's full of ambiguity and context-dependent meanings. How do you write a rigid mathematical rule for an idiom or for sarcasm? How do you program a dictionary to understand an incomplete sentence? Manual rules simply failed to capture the incredible flexibility and nuance of human communication.
The real solution finally arrived in 2017. Researchers at Google published a completely groundbreaking paper titled "Attention is All You Need." This paper introduced the transformer architecture, and it entirely changed how machines process language. This was the spark. It ignited the modern AI era of large language models.
So, unlike older models that had to read words one by one in a strict sequence, transformers use what's called an attention mechanism. This allows the system to evaluate the relationships between many different words simultaneously across enormous passages of text. By training on massive datasets, modern AI systems predict the next word using deep statistical patterns. This lets them generate remarkably coherent language, without actually thinking like a human does.
So we are left with a profound question. Have we recreated intelligence or just mastered patterns? Building intelligent machines has absolutely helped scientists better understand the human mind, but humanity still doesn't completely understand intelligence itself. The more we study intelligence, the more we realize how extraordinary it truly is. And before machines could understand our language, scientists first had to solve one of the hardest problems in computer science: why computers couldn't understand language before GPT.